friends, today we are going to start with a new chapter, that is adsorption and colloids. When a metal spoon dipped in milk is taken out, it is noticed that the milk particles cover the spoon surface, that those particles they do not go inside the spoon but they are just on the surface. This phenomena is known as adsorption. It is a surface phenomena. Therefore, definition of adsorption: the accumulation of a substance on the surface of another substance due to unsatisfied or unbalanced attractive forces on the surface is called as adsorption. For example, first one, adsorption of acetic acid on activated charcoal. Second one, removal of coloring dye like methylene blue by charcoal. When charcoal is added to methylene blue solution and shaken, it becomes colorless. After some time, as dye molecule accumulate on the surface of charcoal. Why does adsorption take place? The adsorption phenomena is caused by unbalanced forces on the surface of a bulk involving van der Waals forces. These are short-range forces. There is a tendency for a liquid to decrease the surface tension and free energy, and this leads to adsorption phenomena. Terms involved in adsorption: first one, adsorbent, and second one, adsorbate. Now we will see first one, adsorbate. The substance getting absorbed on the adsorbent is called as adsorbate. Second one, adsorbent. The material or substance present in the bulk on the surface of which adsorption take place is called as adsorbent. For example, the acetic acid absorbed by charcoal, where acetic acid is adsorbate and charcoal is adsorbent. And also common example of sponge soaked in water, where water is adsorbate and sponge is adsorbent. Next point, absorption. The phenomena of uniform distribution of one substance throughout the body of another substance is known as absorption. For example, absorption of water by cotton. We know that when cotton is dipped in water, cotton becomes wet with water, which is due to absorption. It is a very important topic. Comparisons between adsorption and absorption. In adsorption, first point, it is a surface phenomenon. In absorption, it is a bulk phenomenon. In adsorption, second point, there is excess concentration of the adsorbate present on the surface of an adsorbent. In absorption, the absorbed substance is uniformly distributed throughout the body of an other substance. In absorption, it takes place with the evolution of heat. In absorption, no heat is either evolved or absorbed. In adsorption, fourth point, it depends upon temperature. In absorption, it is independent of temperature. In adsorption, fifth point, it depends upon the pressure of the absorbate gas. In absorption, it is independent of pressure. In adsorption, the rate of adsorption decreases with the time since available surface area decreases. In absorption, it takes place with uniform rate. In adsorption, 7 point, adsorption of H2 on nickel surface. In absorption, absorption of water by sponge. Other point, desorption. The process of removal of an adsorbed substance from a surface on which it was adsorbed is called as desorption. It is opposite to adsorption. For example, adsorption of gas molecule on solid surface. Adsorption takes place at low temperature. When temperature is increased, the gas molecule removed from the solid surface is called as desorption. Types of adsorption depending upon nature of force of attraction between adsorbate and absorbent. Adsorption of two types: one physical adsorption, second chemical adsorption. Next point, sorption. When a chalk is dipped in ink for a short time, ink is adsorbed on the surface of the chalk. But if it is dipped for a long time, the ink enters uniformly in the chalk, and this is called as absorption. This whole phenomenon is called as sorption. Therefore, definition of sorption: the process in which both adsorption and absorption occur simultaneously is known as sorption. That is a absorption plus adsorption that gives sorption. First one, physical adsorption. The adsorption in which weak van der Waals forces are present in between adsorbate and absorbent is called as physical adsorption. For example, adsorption of various gases on charcoal. Second one, chemical adsorption. The adsorption in which chemical bond is formed in between adsorbate and adsorbent is called as chemical adsorption. For example, absorption of oxygen on a metal surface. Comparison of physical adsorption and chemical adsorption. In physical adsorption, the adsorption in which weak van der Waals forces are present in between adsorbate and adsorbent is called as physical adsorption. In chemical adsorption, the adsorption in which chemical bond like covalent bond is formed in between adsorbate and adsorbent is called as chemical adsorption. In physical adsorption, second point, the heat of adsorption is low and lies between 20 to 40 kJ per mole. In chemical adsorption, the heat of adsorption is high, lying in the range 40 to 200 kJ per mole. In physical adsorption, third point, it is a relatively weak. In chemical adsorption, it is a relatively strong. In physical adsorption, it involves the formation of multilayer of adsorbed particle. In chemical adsorption, it involves the formation of monolayer of adsorbed particles. In physical adsorption, it is not specific in nature. In chemical adsorption, it is a specific in nature. In physical adsorption, 6 point, it occurs appreciably only at low temperature. In chemical adsorption, it occurs at all temperature. In physical adsorption, 7 point, it is a reversible. In chemical adsorption, it is a irreversible.